see this is brewster law. It says when unpolarized light is incident on the surface of any transparent material, the reflected and refracted beams are partially polarized, but for a particular angle of incidence called polarizing angle, the reflected light is completely plane polarized with plane of vibration perpendicular to the plane of incidence. Suppose this is the interface. Suppose you have, this is the transparent material. So this is the interface. On this side you have transparent material, this is air. In this case, suppose this is the beam of light which is incident on the beam of light which is incident on the interface. Now you have, this is reflected light as a refracted light. This is refracted light. Now the brewster law says if this light is unpolarized, the incident beam is unpolarized, this is a field vector in all the direction. You have the field vector can lie in any directions. Field vector associated with the rays forming this incident beam can lie in any direction. Then it says the reflected beam and refracted beam are partially polarized. Reflected beam and refracted beam are partially polarized. Means the intensity in one of the directions is higher than compared to other direction. Let me consider two independent direction. One is a direction which lie in the plane of incidence and perpendicular, obviously it will be perpendicular. A direction which is lying in the plane of incidence. See, all the direction will be perpendicular to this direction of propagation. Whatever be the direction of field, they will all be perpendicular to this direction of propagation, right? So let us consider one of the independent direction as direction which of course will be perpendicular to direction of propagation but lying in the plane of incidence, and other direction as direction which is perpendicular to plane of incidence. Let's consider one of the independent direction as direction which lies in the plane of incidence and other is direction which is perpendicular to plane of incidence. If I split all the electric field into a component, one along the plane of incidence and one perpendicular plane of incidence, if all the field vectors are resolved into a component which is lying along the plane of incidence and other perpendicular plane of incidence, then in this case you will find, if I call this, in this case you will find E perpendicular, the vibration, the intensity of the vibration which is perpendicular to plane of incidence will be higher than intensity of the vibration which is parallel to the plane of incidence. Whereas over here, if we consider this as one of the independent direction which is lying into the plane of incidence and a direction which is perpendicular to plane of incidence, you call it other independent direction, then you will find that you do the same thing. You just resolve all the field vector in direction parallel to the plane of incidence and in direction perpendicular to plane of incidence. In that case you will find I parallel is I perpendicular, whereas over here if I do the same thing, if I choose a direction in the plane of incidence and perpendicular to plane of incidence, in that case I perpendicular will be I parallel. This is unpolarized and hence these are partially polarized. These are partially polarized. But theorem says one more thing. At a particular angle of incidence, called polarizing angle, at some particular angle of incidence we call it polarizing angle, your reflected light is completely plane polarized. Reflected light is, I am drawing the figure, it says this is normal, says at some angle of, at particular angle of incidence called polarizing angle, your reflected light is completely plane polarized with all the vibration perpendicular to plane of incidence, with all the vibration perpendicular to plane of incidence, whereas over here we will have both vibration which is perpendicular to plane of incidence and vibration which is parallel to plane of incidence. We will have here both the vibration which is parallel to the plane of incidence shown by green line and vibration which is perpendicular to plane of incidence, that is shown by the red dot, vibration perpendicular to plane of incidence. So this will have all the vibration, this will have vibration only perpendicular to plane of incidence, whereas this refracted light will have both perpendicular plane of incidence and parallel to the plane of incidence. So this will be the plane polarized light. This is completely a plane polarized light with vibration only perpendicular plane of incidence. With vibration only perpendicular to the plane of incidence. This is also P. This is R. And this angle P is given by tan P equals to mu. And if this is mu 2 and this is mu 1, then I can write tan P equals to mu 2 upon mu 1. Tan P equals to mu 2 upon mu 1. Alright. Now, so that's Brewster law. That's Brewster law. The answer lies in electromagnetic theory. So, answer is electromagnetic theory. We will discuss that in electromagnetic theory. So, tan P is mu 2 upon mu 1. Now, from this, you can also derive one result that reflected light, when it can satisfy Brewster condition, this reflected light and refracted light are perpendicular to each other. We can do it from here. You have the Snell's law. Snell's law says mu 1 sin P equals to mu 2 sin R. Whereas from here, mu 1 sin P is mu 2 cos P. It means sin R is cos P, that is sin 90 minus P, or R is, so R plus P is pi by 2. R plus P becomes pi by 2, right? So you find that reflected light and refracted light, they are perpendicular to each other. Reflected and refracted lights are perpendicular to each other in that case, right? So this is one condition, right? So you can get reflected light plane polarized if the light unpolarized is falling at an angle of P, which satisfies this equation, right? Suppose this is glass slab. Suppose this is a glass slab, and say it's a glass slab. Then can you tell me that whether you have the Brewster condition satisfied over here also? Let's check. Let's try to check it. Whether we have the Brewster condition getting satisfied over here or not. It will be like this. And for this, the ray will go like this is the emergent ray, right? This is emergent ray. You can draw the normal. This is normal. Now we have to check whether Brewster condition is satisfied over here or not. So this is R. Just if this is R, this will also be R. This will also be R. And this will be of course P. Then Brewster condition is satisfied. This will be mu 1. If tan R is mu 1 by mu 2. Brewster condition is satisfied if tan R is mu1 by mu2. If I prove tan R is mu1 by mu2. Now here we have tan P equals to mu2 by mu1. Here Brewster condition is satisfied. So this is tan pi minus T minus R is mu2 by mu1, or cot R becomes mu2 by mu1, and that will give you tan R is mu1 by mu2. So you see the Brewster condition is satisfied over here also. So this will also be a plane polarized light. This will also be a plane polarized light, and this will be partially polarized with more vibration parallel to the plane of incidence and less vibration perpendicular to the plane of incidence. Right? Now if I keep one more glass slab over here, you have one more glass slab kept at this position like this, then what do you see? What do you say about this? Obviously it will satisfy the Brewster condition because these rays are parallel. So obviously this is P, and again you have the Brewster condition satisfied, and reflected light is coming out with all this vibration perpendicular to plane of incidence. Right? Now here you have again a refracted light, and again a reflected light over here, and again emergent light. So here also you can say this is partially polarized with more vibration perpendicular to plane of incidence and very small vibration perpendicular to plane of incidence. And again Brewster condition satisfied, it will come out with all this vibration perpendicular to plane of incidence, and this will be having most of this vibration perpendicular plane of parallel to plane of incidence and very small vibration, very small intensity which is perpendicular plane of incidence. See, you are seeing that all the perpendicular vibrations are getting sieved out at this point, this point, this point, this point. So the amount of perpendicular vibration go on decreasing. If you have 9 to 10 such glass slab, then the ultimate, the light which is emerging from the final slab will be almost plane polarized with all its vibration parallel to the plane of incidence. Because at every position, see, at every glass slab you have two rays coming out with vibration perpendicular to plane of incidence. So the perpendicular vibrations are getting sieved out at every glass slab. So after 9 to 10 glass slab, the emergent light is practically, for all practical purposes, will be almost plane polarized with all its vibration parallel to the plane of incidence. So that's how we can produce the plane polarized light by refraction. Right? You can produce plane polarized light using refraction.